Suppose a marketing company randomly surveys 351 households and found that in 204 of them, the woman made the majority of the purchasing decisions. Construct an 88% confidence interval for the population proportion of households where the women make the majority of the purchasing decisions. So we're constructing a confidence interval for the population proportion. This is very like what we did when we constructed a confidence interval for the population mean. We're going to be doing many of the same things. We're starting off by finding the point estimate for our population proportion. So this is our best guess for our population parameter given our sample. So in this case, we want P prime, our sample proportion. So P prime is the number of members in a population, number of members in the sample that has the characteristic we're interested in. In our case, it's the number of households where the woman makes the majority of the purchasing decisions, divided by the total number of members in the sample. Okay, so in our case, we have 351 households that we surveyed, and 204 of them have the desired characteristics. 204 of them in which the woman makes the majority of the purchasing decisions. So let's throw that into our notebook, and we can find out the decimal value of our P prime here. Okay, let me close that. Okay. So notebook, we have the number of individuals in our sample that have the characteristics, so the number of individuals in our case where the woman makes the majority of the purchasing decision. So that's 204 households with that. And then the number of households total that were surveyed is 351. And so our P prime, our sample proportion, is X divided by N. So let's print that out so we can see what's going on, what we get. So our sample proportion is 0.58. That means from our sample, about 58% of households surveyed said that the woman makes the majority of the purchasing decisions. Okay, so let's copy that and let's put it in for that first value. So our sample proportion is 0.581965 about. Next, we want to find alpha over 2. Now we're going to get this from our confidence level. Our confidence level is 88%, right? So our confidence level is 88%, or as a decimal, it's 0.88. The alpha then is 1 minus the confidence level, which means 1 minus 0.88. And we want half of that, right? We want half of that alpha. The reason we want half is that we want to look at our normal distribution here. We have our P prime right here in the middle. That's our mean of all our sample proportions. Okay, or at least that's our best approximation. We're constructing a confidence interval, so we're going to take an area about that where we have 88% of the area. Okay. That means that what we have, we're interested in what we have left in each tail. So together, these two tails will have 100% minus 88%. That's our alpha, okay, or 1 minus 0.88 in decimal form. But since we have symmetry, each tail will have alpha over 2 of that area. Okay, so we're looking for that alpha over 2. That's what we're looking for. So our alpha is going to be 1 minus 0.88. So let's go to our notebook. Alpha is 1 minus our P prime. No, I'm sorry. 0.88, our confidence level. Maybe I'll add that in. Confidence level is 0.88. Alpha is 1 minus the confidence level. And we are really looking for alpha over 2. Okay, alpha divided by 2, half of that alpha. So I'll just take whatever I get there and divide it by 2. And let's see what that is. And if you notice, I missed an A there. So alpha over 2. There we go. So let's run that. 0.06. Okay. So let's put that in right here. Alpha over 2. So that means graphically that there is there's an area of 0.06 in this tail. There's an area of 0.06 in this tail. Okay. So next up, we are looking for Z alpha over 2. Z alpha over 2. So that is the Z value. Let me write this in green. Z alpha 2 was going to be right here. That's the Z value with alpha over 2 area above it. So we are looking for this Z value right here. So we want an area of 0.06 above that Z value. Okay, so let's go to our notebook. And I'll just type Z. So we know the probability, right? The probability that we're looking for, the area that we're looking for, is 0.06. That's the area above the Z value. So since we're looking for a Z value, we know the probability, we're using Q norm. And plug in the known probability of alpha over 2. That's what we're plugging into the p-value. So that'd be 0.06 in this case. Okay? And lower tail, well, if we look here, Z alpha over 2, we want that alpha over 2 area above it, right, for this particular guy. So that alpha over 2 area is not in the lower tail, it's in the upper tail. So lower tail is false. Okay, so let's get that Z. So our Z alpha over 2 is 1.55 about. So let's copy that, paste it in. Okay. Okay, next up, margin of error. Margin of error. So margin of error, we're going to calculate this similar to how we did it when calculating the margin of error for our population mean, when we were creating a confidence interval for the population mean. In that case, we had Z alpha over 2, and then we multiplied by an approximation of the standard deviation from the central limit theorem. For the central limit theorem for proportions, the standard deviation is P times 1 minus P over N, where P is the population proportion. Of course, we don't know the population proportion, so we're going to approximate. We're going to give it our best approximation, which is our point estimate P prime. Okay, so that's what we are going to calculate for our margin of error. We have all those pieces, right? So let's go here. So our margin of error is going to be our Z alpha over 2, which we've stored in our variable Z, okay, times, if we look here, so Z alpha over here, 2, and then we'll multiply it by the square root of all this stuff under the square root. So multiplied by the square root of, and then we have P prime times 1 minus P prime divided by the sample size N. Okay, so make sure you take a look at that, make sure you see how that corresponds with the formula here. Okay, okay, we're actually going to need the answer to that for our problem. So let's type in E there, so we'll print out, and we have our margin of error, 0.0409. We are 88% confident. So now that we have our margin of error, we actually want to construct the confidence interval. Okay, We are 88% confident that the proportion of households in the population where women make the majority of purchasing decisions is between some value and some other value. So to find those two values, we do, again, very similar to what we did when we were looking at our looking at this for a confidence interval for our population mean. Okay, so our confidence interval, and we're just going to take our point estimate and subtract our margin of error, add our margin of error. So our point estimate for calculating the mean was x bar, but we're not calculating mean, we're calculating we're estimating the population proportion. So our point estimate is a sample proportion p prime. And so we're going to take p prime, we're going to subtract that margin of error. We're going to take that p prime, that sample proportion, we're going to add the margin of error. And so that's going to give me the two values in my confidence interval. That's going to give me the range of values. Okay. So let's use our notebook. So we have the pieces. We're going to use our p prime. And I'm just going to use the variable since I have it stored. But if you want to, you could copy and paste the 0.5811. But do try to copy the whole thing. If you don't add enough digits, then you won't have a good enough approximation for the answer to be marked correct. So p prime minus the margin of error, p prime plus the margin of error. Okay, let's run that, and there we have it. So let's copy and paste these. We want to make sure the smaller value goes first. Okay, for these problems, it expects the smaller value first. Okay, so we are 88% confident that the proportion of households in the population where women make the majority of the purchasing decisions is somewhere between 0.54 and 0.62, or as a decimal, or I'm sorry, as a percentage, somewhere between 54% and 62% of households. That's the percent of households where the women make the majority of purchasing decisions. We're 88% confident that the true population proportion is somewhere between 54% and 62%. Okay, so submit, and we have it.